This class is the first class of project controls, and we also discuss the unvalue analysis EVA, one of the popular project control analysis. With that, the learning objective today are recognize the importance of project controls, analyze the project schedule status using the work time relationship method, and the last one explain the basic elements of EVA and value analysis and terminologies used for project performance analysis and forecasting. And with the basic element of EVA in the next class, we will use unvalue analysis EVA to forecast and evaluate the project performance. So let's talk about the project controls, how that is important. And you plan for the project, so far we can understand and be able to estimate the project. We can schedule the project, and we can assign who are going to work. So that all that we have discussed, the work breakdown structure, the organizational breakdown structure. So we have the times, the schedule, the resources, resources should be allocated in terms of labor, material, subcontractors, the budget. It means that the estimate the project costs, responsibility, organizational breakdown structure, and performance standards. Now, with that, we can have plan for the costs, plan for schedule. Then now we can plan that project into action. It means we spend time, spend resources, spend money on the project. We need to know what is the status of the project in terms of, are we behind or ahead of schedule? Are we over or under budget? All of that show the importance of project control. So as you can see in here, in this box for the control, we want to know the time behind or ahead of schedule, under or over budget, specification, whether the actual work meet the specification to show the quality of the work. So that need to be monitored as well. So control is about to monitor the project and see is there any deviation between the plan and the actual, and what are the corrective actions should be done when we see the deviations, variance between the plan and the actual work. So with that, we continue to use different methods to monitor and control the project. The first that we discuss is the work time relationship. So in terms of the work time relationship, think about these scenarios. Some of you have an intern in an engineering firm, some intern in construction firm, or other work. Then just imagine this scenario. How much work has been completed in the following scenarios? All design calculation completed. This is you very familiar and very excited to do. Design calculation, use your equation you learn with your calculator, with the laptop, etc. to do the calculation. So all design calculation completed, but that not stop the design or engineering work. We need to produce drawings. In this case, half of the drawings produced, and not only drawings. You need to specify how the work should be done, what our material should be for the project, what either tolerance should be for certain work, what either technicals involved to make sure the work that completed physically is what it intended when you design. So that need to have the specifications, and in this case, 1/4 of specification are written. So with that scenarios, can you imagine how much the design work has been completed? Pause the video, think a little bit, and see how much is completed. Can you be able to do that? And in the face-to-face class, I posed this question. Different of you would have give different uh, numbers in terms of how much work completed. Some may say 50%, some may say 75%, some may say 40%, 30%, things like that. So it's very inconsistent throughout the people when we assess the work. So that is a challenge for project control, especially in these scenarios. The design of calculation, we may count by how many equation, how many calculations we are using. For drawing, we count how many drawings we have produced. Specifications, we may count how many pages we have finished specification. But combined together, different work in here have different unit of measure. So that is the important. No common unit of measure throughout across these three engineering work items. So that is the challenge. And now that why the work time relationship come to make sure we be able to have a common units of measure. And let's go to the note that we have in today's for the work time relationship. And that here, because there are no common unit of measure when you want to see whether project, how much percent project completed. In this case, to make sure they have a common unit of measure, in this case, the percentage of completion at the units of measure across all the work completed. So percentage of completion at a common unit of measure instead of how many calculation you done, how many drawing you produce, how many specification pages we have completed. And then we need to have a criteria for determining the percent complete must be developed and agreed. Because when someone asks you to do the calculation here, when people assess how many percent you already complete your design calculation work, you may say 50%, others may say no, only 40%. So that need to have criteria to determine percent complete so that we have a consistent from person to person when we estimate percent complete. And then we have a weighting multiplier assigned to each task to define the magnitude of the effort for compared to the overall work. In the engineering design scenario that you have here that I just showed earlier, in this case, as you can see, we need to see the relative effort between the design calculation, production of drawings, and writing the specification. And that we call it weighting multiplier. So let's see one example here and how people develop the work time relationship. So that is one design work example. Just elaborate the one that the question we posed in the previous slides. And in the design work, we can have review backup material, anything done with the client give us to us about the project. We can do the survey, the work, etc. And then we do the design calculations. We can initial drafting based on the calculation, and then we get some feedback from clients, from other parties. We can do the final calculations, and then we produce the drawings, and then get the approval from the clients of your drawings specification. So with that one, let's see the multiplier, the weight multiplier for each work. In here, 5% for the review backup material, 10% for design calculation, etc. for the until drawing approval, 10%. The total here will be 100%, 1 point. And the project timing, first 10% for review backup material, 10% to 25% of the time, it design calculation, and then in the last 10%, finally in the last 10%, 90% to 100% of project timing, it will be approval of drawing. So with that, we can be able to develop the work time relationship in the next slides in here. We can be able to do the and draw the review backup material, the time between 0 and 10%, and the effort is 5%. So you have 5% time 0 to 10%. Time is the horizontal axis, percent time, vertical axis, percent work. In terms of time, for the review backup material, 0 to 10%. In terms of effort, 5%. So you have that in 5%. Similarly, we have a design calculation, effort 10%, and the time span from 10% to 25%. So we can have the design calculation here from 10% to 25%, and the effort is 10%. So from 5% plus 10% of the design calculation, you will get 15%. And then continue for each of the tasks like that. We can get the work time relationship for each of the tasks relative to the time and relative to the percent of work. And when we connect the dot together, we can be able to, in the bottom graph, be able to find out the work time relationship for the whole design work that include a few tasks that you see in here. So that is the work time relationship between the percent time and percent work. It's still abstract. In the next problem 1, you will, and the next video, I will show you how to develop this work time relationship in one problem.